Okay, so looking at this, the first thing that we want to do, we want to show that if n is a composite, so that's why you let n equal ab, where a and b are integers, because then n has factors, see? A times b. A is a factor, b is a factor. Then there exists a factor of n not equal to 1. So, and at most equal to the square root of n. So what we're going to do here, we're going to use proof by contradiction. We're going to contradict this statement. So we're going to do proof by contradiction. So we want at most, so this is what this is saying, we want the factor not to be equal to 1, and we want at most the factor to be, so we want it to be less than or equal to root n. Okay, so by contradiction, let's assume the factor a is greater than root n. Okay, and then we're going to prove that this actually can't happen, that it will be false. All right, so if a is greater than root n, and it says there also that, just in our original statement too, let's say which one's bigger. So we're going to say that a is less than or equal to b as one of our factors. So if a is greater than root n, then basically b will be greater than a, which is greater than root n. So b is greater than root n, and a is greater than root n. So what that means is a times b would be greater than root n times root n. So ab would have to be greater than n. But n actually equals ab. So this is a contradiction to our original statement. So therefore it can't be true. Now just with the one thing, let's just assume that one of the numbers is equal to 1, okay, because it says a is not equal to 1, so the contradictory statement, let's just say a was equal to 1, then n would equal a times b, which is 1 times b, so that means that n would only have the one factor, b, so therefore it's not composite. So therefore it can't equal 1, so therefore, by contradiction, the original statement is true. Okay, I won't re-state it, but the original one would be true.